Okay, so we want to continue finding, why is my pen messed up? Continue finding increasing and decreasing intervals and relative max and mins of functions. Here we're just going to look at a trig example. Just keep in mind that we're looking over the interval from 0 to 2 pi of this function right here. So first thing we want to do is take the derivative and set the derivative equal to 0 and determine if there's any times in which the derivative is 0 or undefined. Since there's no times in which this is undefined, then we're just going to set the derivative equal to 0. So we get cosine of x is equal to 1/2, and cosine of x equals 1/2 at pi over 3 and 5 pi over 3. So there's a lot of values that we need to consider here, so I'm going to make a pretty big chart down here at the bottom. Let me set that up for you. Okay, since we're only going from 0 to 2 pi, and we have two critical values of pi thirds and 5 pi thirds, so we're going to start off with 0 comma, plugging in 0 to this function gives us 0, and then pi thirds, plugging that in, gives us pi minus radical 3 over, excuse me, I can't even read my own writing. And then 5 pi over 3 is going to be 5 pi plus 3 radical 3 over 6. And then at the end is 2 pi comma 0. So our intervals, we're going to have a couple intervals here. We're going to go from 0 to pi over 3. Pi thirds to 5 pi thirds, and then 5 pi thirds, oops, that's a 3, to 2 pi. Oops. So a function value, an x value that's between 0 and pi over 3 is pi over 6, so f prime of pi over 6. The easiest one between pi over 3 and 5 pi over 3 is pi over 2, or pi would work, or even 3 pi over 2. And lastly, between 5 pi thirds and 2 pi, the only really easy one to work with is 11 pi over 6. So using my graphing calculator, I plug these values in, and I'm just going to write the values out. So using the graphing calculator, I just plugged in pi over 6, pi over 2, 11 pi over 6 into my derivative function here. I see no reason why you need to watch me do that. So it's negative on this interval here, positive on this interval, and negative on this one. So obviously we have some increasing and decreasing intervals on our function f. So our conclusion is the function is decreasing here, increasing, decreasing. Just give myself a little bit. So my function is going down over here and also going down here, but it's increasing in between those two. So let's just choose another color. So it's increasing here. So you'll notice that there's a min in between these two and a max in between those two. So let's just write that out. So there's a min here and a max up here. So let's write out our answer. I'll just write that out and you can verify. So here's my complete answer. Here's my increasing, decreasing intervals and relative max and mins. Here's a look at the graph right here. That's the wrong graph. Hold on. So here's a minimum right here. And here's a decimal approximation of that point. And here's a relative maximum up here. And notice that my function only goes from 0 to 2 pi, where 2 pi is 6.28. And there's my function right here. Let's take a look at the graph of the derivative of this function at the same time. So here's a graph of my derivative here going from 0 to 2 pi. My derivative is written right there. Notice that most of the time my derivative is above the x-axis in between these two x values here. And notice those x values correspond to where the function changes from being an increasing function to a decreasing function. So notice that the derivative is positive here and my function is increasing here. So a positive derivative implies that the function is increasing. And notice here that the derivative is negative and my function is decreasing, and my derivative is, my function is decreasing here and my derivative is negative over here. And when it changes from negative to positive, my function changes from decreasing to increasing, so you have a relative min. And notice that where my derivative changes from positive to negative, so my function changes from increasing to decreasing, you have a relative maximum.